Today what I have for you to watch is a review of the different types of calculations that we've done with stoichiometry and how you can recognize what each type of calculation is. So when you get to the test on Friday, you will know, hopefully, just by reading the story problem, what kind of calculation you need to do and how to go about doing it. So let's start with a definition right at the top. Stoichiometry involves reaction calculations, and I'm abbreviating here because my boxes are little, with balanced equations. All of the calculations we've done so far have been based on a reaction and a balanced equation, and we've used the comparison several times of how that's kind of like a recipe. You have to know what's going in and you have to know what's coming out. There were three types of calculations that we did with these balanced equations. The first kind that we learned was the shortest. So the first type of calculation was a mole-to-mole calculation. These are the short ones. There's only one step. So how do you recognize a mole-to-mole calculation from a story problem? Well, first of all, you would be given an amount in moles in the question. You would be asked for an amount of moles in the question. And then if you see those two things, given moles and asked for moles, you know that these calculations are really only going to be one step. Beyond where you put your given information, there's only one more step. So, how do we do an example for a mole-to-mole problem? Well, first we better have a balanced equation. If you look down at the bottom of your screen, there's an equation for us to write formulas for and balance. It says silver 1 nitrate. So our first compound will be silver, and we know that that's a +1 from the 1. Nitrate, we have to look up on our chart. Look up on the chart, that's a -1. +1 and -1 balance, so that's a good formula. Then it says plus copper. And that produces copper 2 nitrate. So again, we're going to have our nitrate. This time it's with the copper. And we need to check our charges. Copper is a +2 because of the Roman numeral. Nitrate is still -1. That means I need 2 nitrates to balance out the copper. And our last product is silver. Now we need to balance this equation. Check your silvers, check your nitrates. You need 2 here. Check your coppers. Okay, good, but when we change the nitrate, we also change the silver. So we'll need a 2 there as well. Now we have a balanced equation that we can work with. So for a mole-to-mole problem, the story problem might sound something like this. If 0.75 moles of AgNO3 reacted with excess copper, how many moles of copper 2 nitrate would be produced. Starting with moles and ending with moles. This will be a one-step problem. Start with what you're given. 0.75 moles of AgNO3. We need to cancel the moles. So where do they go next? On the bottom, we use the numbers from the balanced equation. In the balanced equation, there's 2 moles of AgNO3. For every 1 mole of copper 2 nitrate, moles of AgNO3 cancel. 0.75 divided by 2, check your sig figs, and you should get 0.38 moles of copper 2 nitrate. Make sure on the test that you label what unit is it, moles, and also what substance is it, copper 2 nitrate. The next kind of calculation that we did, we added a few more steps, and we called those mass-to-mass calculations. So how do you recognize a mass-to-mass calculation? Well, you'll be given a mass. And the key to differentiating this between limiting reactants is to note that you're only given one amount of grams. For a simple mass-to-mass problem, we were only given one amount of grams. Then, as you might expect, the question would also ask you for grams. And these are the calculations that take 3 steps beyond where the given information goes. So these are our 3-step problems. And again, we'll do an example. A story problem for a mass-to-mass calculation might sound something like this. If 10.2 grams of copper react with excess silver nitrate, how many grams of silver would be produced? So you start with what you're given, 10.2 grams of copper. And now we need to do 3 steps. The grams of copper need to be canceled. So you look up the mass on the periodic table, 63.55 for every 1 mole of copper. And here we've canceled our grams. Now we need to cancel moles of copper, so we look at our equation. There's 1 mole of copper in the equation. We're looking for silver. There's 2 moles of silver in the equation. Now we've canceled our moles of copper. And from here we need to change moles of silver back to grams of silver. So look at the periodic table. For every 1 mole of silver, there are 107.87 grams. And then we've canceled our moles of silver. Check for sig figs, do your math. You should end up with 34.6 grams of silver. these two kinds of calculations can be used to find what we call the theoretical yield. Remember, the theoretical yield is how much should be produced. This is your theoretical 100%, how much should be produced. If you were asked to find an actual yield, or if you were asked to find the percent yield, you'd have to be given the actual yield in the question, and then you'd have to divide those, just like when you find your grade. Last type of calculation we called a limiting reactant. I'm just going to abbreviate limiting reactant. And we know that those were a little bit different because something in that reaction is running out. Something runs out or limits how much product you get. How do you recognize a limiting reactant question? Instead of being given one number in the question, you would be given two numbers in the question, two amounts. And usually we've done those in grams, but you can also do them in moles, but given two amounts. You just have to be careful that you don't confuse this with a percent yield problem, where it would say what percent was actually yield if this much was actually collected. What would you be asked for in a limiting reactant problem? Many times you'll be asked for a limiting reactant. Big red flag right there. What is the limiting reactant? But you will also be asked for the amount of one of the products in either grams or moles, depending on what you started with, what information you have. What do you have to do for a limiting reactant problem? You have to do 2 of the previous calculations. So do 2 of either the gram to gram calculations or the mole to mole calculations. The key here is for a limiting reactant problem, you have to do 2. 2 of the gram to gram calculations or 2 of the mole to mole calculations. So let's see if we can squish an example in here. An example for a limiting reactant problem might sound like this. If 15.3 grams of copper react with 20.6 grams of AgNO3, what is the limiting reactant and how much silver will be produced? Now we have to do 2 calculations. We're being given grams and asked for grams here, so these will be long ones, 3-step calculations. And we'll figure out the limiting reactant and how much silver would be produced. We'll do the copper one first. And I'm going to leave the substance labels off here to save a little space. Look up copper on the periodic table because we need to cancel the grams. That's the number of grams in 1 mole. Look at the equation. There's 1 mole of copper in the equation. And I'd like to know how much silver is being produced. There's 2 moles of silver in the equation. Then I need to change the moles of silver to grams of silver. Check your sig figs, do your math. You should come up with 51.9 grams of silver. But we're not done, because we also need to find out how much silver would be produced from the silver nitrate. So again, we set up just like before, 20.6 grams of silver nitrate this time. Look at the periodic table, add up your pieces. Silver nitrate weighs 169.88 grams for every mole. Look at the equation. There are 2 moles of silver nitrate for every 2 moles of silver. You might notice that those are going to cancel out. Then we need to change moles of silver to grams of silver. Do your math, check your sig figs. You should get 13.1 grams of silver. So how do you decide what your limiting reactant is? Look at the 2 amounts of product you have. Whichever is the lowest amount of product will be the reactant that runs out first. So that was the 13.1. That means the 20.6 grams of AgNO3 will run out first. So the limiting reactant is AgNO3. That's part of our answer. And then we have to say how much product do we get? How much silver is produced? It's always the lower of the 2 amounts. So that's 13.1. Okay, I think you should be ready for the test. Remember, there are 3 types of calculations here. Mole to mole, which is 1 step. Mass to mass, which is 3 steps. And limiting reactant, which is 2 of the other kinds of calculations. You could also be asked to find the percent yield. And remember that the percent yield, see if we can find some space here, the percent yield is the theoretical on the bottom. That comes from either a mass-to-mass problem or the mole-to-mole problem. The actual yield on the top, that would have to be given in the question, usually with some keywords like actually collected or is collected. And then of course, to make that a percent, you have to times by 100. All right, you should be all set. Good luck with your review packet and your test.